All right, so we're going to start looking at the groups now. We've looked at the periods. We know that the energy levels match up with periods. Now we're going to look at groups. Some groups are labeled. They actually have names. For instance, group 1, which would be this group right here. Hydrogen is not included. They are called the alkali metals, ending with I. Alkali is group 1. So these alkali metals, move this over here a little bit. They are group 1, except for hydrogen. They are the most reactive metals. Remember, hydrogen is a nonmetal, so it doesn't count. So these are the most reactive metals. They have an S1 configuration, meaning there's only one electron in the valence shell. So you can see it right here. It doesn't matter what energy level they're on, there's only one in the valence shell, which means they only have one electron to lose, which is kind of easier to do than losing more than one. So what happens is, watch this little dude. Because they're stable as +1, that gets gotten rid of or borrowed or shared, depending on what you're looking at. And it becomes a +1 atom. Now looking at this is, it's called isoelectronic with neon, meaning that the atom will look like neon with sodium characteristics in it, because it's got the 8 in the shell, which matches up with neon, which is in the previous energy level, which is in the energy level 2. Right? All of these metals, these alkali metals, they're explosively reactive. So as you go down, they get more and more and more and more reactive, where you get to francium, where it is so reactive, like even in the air, if it comes in contact with air, this happens. It's so explosively reactive. So it has to be kept in oil, a non-reactive oil, so that it doesn't react. It's so reactive. The next group we have are the alkaline earth metals. So alkaline earth metals, group 2. And these metals are reactive, but they're not as reactive as group 1. This is due to the fact that they are S2 configuration, meaning everything down that line, everything down that group has 2 valence electrons. Doesn't matter what energy level they're in, there's always going to be 2 in the outer shell, which means they have to lose 2 to become stable, to have that 8 valence shell, which is why it's a little less reactive than group 1, because group 1 only has to lose 1, whereas this one has to lose 2. So it loses the 2 and it becomes stable, just like group 1, but it has to lose 2. It becomes +2. That means there are 2 more protons than there are electrons. And again, this one is isoelectronic. Magnesium in this case is isoelectronic with neon, because it has the energy levels of neon, but it's magnesium, has the characteristics of magnesium. All right, this next group is 3 through 12, right here through here. These are all the transition metals. Now these transition metals, these are the ones where you're going to find the colored compounds, like copper is blue, manganese is orange, permanganate, that's going to show you purple. They have multiple oxidation states, which means they form more than one type of ion. Here are some examples. You've got iron with +2 +3, copper +1 +2, cobalt +2 +3. All right, then you've got group 17. Move myself over here. And group 17 is right here. Notice we don't include that one for a reason. These are called the halogens. Group 17, they include the diatomic elements. There are more than this, but they include the diatomic elements, fluorine, chlorine, bromine, and iodine. Now, what's really cool about this group is they have all three phases present at room temp, which means the gases are fluorine, chlorine, bromine is liquid, iodine is solid. These are the most reactive nonmetals. You had the most reactive metals is group 1. Now group 17 is the most reactive nonmetals. And this is because they have 7 valence electrons, which means all they need to do is get one more or gain one more electron, and it is stable at a -1. So it grabs one, typically from the first group, and it becomes stable. And it looks like argon, the next one, the next noble gas, which we're getting to in a second, which is group 8, the noble gas, the inert gases. This is all of that, including helium. These guys are group 18, which means they have 8. It's stable, unreactive. They have 8 valence shells, valence electrons in the shell. That means all of them all the way down have 8. With the exception of helium, which only has 2, making it stable because it's a special little element. And this is the stable configuration for hydrogen and lithium. 2 noble gases, though, can be made to react. And they have oxidation states other than 0. You've got krypton and xenon. Notice the helium is 1s, again, only has 2 in the valence shell. That's it. That's all there is. So hydrogen and lithium will look like helium, whereas krypton and xenon, they can be made to react. You've got the +2 here. Xenon is +2 +6. Okay, so now we have the rare earth metals. These are down here. These are the anthanide and lanthanide series. So lanthanides follow 57 through 71, this top one, and they're found together in nature. Where the anthanide from 89 to 103 are mostly man-made. And they're the transuranium series. All right, so now we're going to have the blocks. The you're looking at what orbitals, what suborbitals that they fill. So we already know they have levels. Now we're looking at the orbitals in the levels. So this one, this series, the first 2 columns fill the S sublevel. The groups 13 through 18, they fill the P block, or the P suborbitals. And then all the ones in the middle, I'm sorry, you can't see it right here. These are the D sublevels. And then finally you have the F sublevels right here down in the lanthanide series. All right, so that is it for right now. If you have any questions, please don't hesitate to ask. And I hope you guys have a great day.